A conversation history feature looks simple until the database boundary gets blurry. Are you storing raw messages, parsed records, tool results, or all of them? This lesson stores and queries conversation messages with a small database layer. SQL parameters, transactions, and returned records should be explicit enough for later AI code to trust. The vocabulary is connections, SQL parameters, transactions, repository pattern, and ORM trade-offs. A connection is the link to the database. Parameters keep values separate from SQL text. A transaction groups changes. A repository gives the rest of the app a narrow interface. An ORM can help, but it also hides some SQL behavior. Open the file conversation_store.py and find the functions that write and read messages. Look for parameterized SQL and for the shape returned to the caller. Ask whether the rest of the app can store a message and fetch it back without knowing table details. If yes, the database layer is doing its job. Keep the database contract small. The caller should ask for operations like save_message or list_messages, not build SQL fragments or know which table stores which column. Run the demo and watch the insert, query, and return messages. The output should show stable fields, not raw database cursor objects. Prompts, summarizers, and retrieval steps need predictable records. They should not care how the rows were stored. The test should cover insertion, ordering, filtering, and invalid input. They should also prove that user text is passed as a parameter rather than pasted into a SQL string. That is a security boundary. Even in a small lesson, parameterized SQL is the habit to use every time user text touches a query. Ordering matters for conversation history. If tests do not lock down the sort order, a prompt can receive the same messages in a different sequence and produce confusing results. Direct SQL is transparent and works well for small focused data access. An ORM can reduce repetitive mapping and relationship code, but it can also make queries harder to see. Use direct SQL when the data access is small and clear. Reach for an ORM when the domain model and relationships justify the extra layer. Transactions matter when a logical operation touches more than one row. Either all related changes are committed or none of them are. That rule keeps partial state from leaking into later reads. An interviewer might ask, when would you use raw SQL instead of an ORM? A strong answer is, I use raw SQL when I need explicit queries, simple tables, or performance clarity, and an ORM when object relationships and repeated mapping become the main complexity. In both cases, I keep a narrow repository interface and test the query behavior.